Let's learn about the formula that is associated with work. For this, I'm taking up a scenario. I have an object of mass m. On this, let's apply a force of F. And this force displaces this object with a distance of or displacement of s. Then the work done by this force, the work of this force or done by this force is nothing but the magnitude of the force into the displacement. That's it. Right? That's your formula. So work is equal to F into S. Very simple formula. You guys can remember this, not an issue. Let's talk about the unit of work. So work unit is named after a person. So we use capital letter, in this case capital letter J, like Newton, right? The unit for force is Newton. Since it's named after a scientist, we write it as capital letter N. Here too, it's named after a scientist, so it is capital letter J. If you want to spell it, it is Joule with J being the small letter. It has to be small. It can't be capital. Okay, so this is a rule. Since it's named after a person, this is the rule that you need to follow. Remember this. Next step is to define this joule. See, my rule is always this. Whenever you have to define any unit, always start with the formula. Work is equal to force into displacement. Since we always define for one, whatever it is, joule or Newton or whatever it is, the LHS will be 1. We have to make the RHS also 1. So here it is 1 Newton into 1 meter, right? So now we can define it, right? We have said to have done 1 joule of work if we apply a 1 Newton of force and displace the object by 1 meter. As simple as that. Right, guys? So let me read what I have written over here. We said to have done 1 joule of work if a 1 Newton of force leads to displacing an object to 1 meter. The framing of the answer is left to you guys. The language is left to you guys. But yes, always start with the formula. Draw a diagram if possible. In your exam, that is. Here you have to draw while taking notes, that is. And yes, and the wording. Okay, this sequence of things will help you. See, you might not realize this now, but for your future grades, whatever stream you go to, you need to learn such discipline. Okay, guys. Now, the last question that I want to discuss with you guys is work a scalar quantity or a vector quantity? So let me recall what is scalar. Scalar is nothing but quantities which has only magnitude. Vector is quantity which has magnitude and direction. Okay. Now, what do you think work is? I'll give you guys a clue. Work done is a measure of the amount of energy transferred. Now think in terms of energy. A battery has energy, an object held above the surface has energy, a rubber band which you pull has an energy. Right? Different scenarios. All of this has energy. A dam holding water has energy. The result is force. That has force. That has direction. A force has direction. Work per se, does it have direction or not? Energy, does it have direction or not? Right? It is easier to understand work in terms of force. So energy, not force, sorry, energy. So energy does not have a direction. Work does not have a direction. And thus, work is a only magnitude quantity. So it's a scalar quantity. Okay, guys. Yes, it might be counter, we are talking about force, we're talking about displacement. It's kind of counterproductive or it counters your understanding. But work is scalar quantity, right? It is the energy that we transfer or acquire and all of that. So we'll understand this in time. Okay, guys. The resultant of work is a force. If you hold an object and leave it, it exerts a force on something that is underneath that. If you drop a ball, anything is below that will experience some kind of force, is it not? So force has direction, that I agree. But work per se does not have direction. Okay, so think in terms of energy, you'll be able to kind of realize it. So try to realize things, just don't accept it. Think about it. That's how you learn all of this topic better. Okay, as of now, you guys have to pause and copy all of this. and this too has to be copied.